I told you about plastic tape.
Now, a light string of elastic natural length 2 meters and elastic constant 8 newtons per meter is stretched between 2 points 3 meters apart on a horizontal surface. So, what you got to remember is that there's an equilibrium point in the middle, okay? And the equilibrium point, it's meant to be 2 meters long, but it's actually 3 meters long. Okay? So what you have is basically each half would have 1 meter natural length and 0.5 meter extension on each side. Would you agree with that? Because it's distributed evenly. And it doesn't matter what way you write the order, okay? Then they say between 3 points horizontal surface. They then decide to put on a 0.01 kilogram mass, because we're going to put it into kilograms, okay? And that's dead center at the moment. Okay? Now, what they do then next is they pull it 3 centimeters in one direction. So we're going to move it from here to here. Okay? And that's by 0.03 of a meter. That's your amplitude, because it's going to bobble. I'll use a red thing to denote this now. Simple harmonic motion will have it's going to go this way, back again, this way, back again. Okay? So that's how it has to work. Now, it's fastened to the midpoint, so it's only one string, both sides of the string. Find the time taken. It's a time question. Time questions involve the sine or cosine function. Okay, so you know you're going there eventually. Okay, so let's do this. Force equals ma. We're trying to line up a equals minus omega squared x to find the omega value. Okay, so we want it to be negative. So which one's the bigger force? The force left or the force right?
The force left.
Force left is bigger than force right at this point here, because of the bigger extension. So what we're going to do is force equals force right minus force left. And what that's going to do is it's going to give us a negative value. Okay? So force is mass by acceleration, which is 0.01 a. Force to the right, it's k times extension. Okay? So its extension is its k value is 8. Its extension, it was 0.5 meters per side, but then this one has an extra 0.03. So this one is going to be 0.5. Before I do the 0.03, I have to do it in terms of x. Okay, so I'll just put it. I denote x as the extension. Okay, so it's going to be 0.5 plus x, the extension in this direction. 0.5. Sorry. This is the force going to the right. So this one in turn has lost a small bit of its extension. It's lost x on its extension because it's closer to the wall than the other side is. So it's actually going to be 0.5 0.5 minus x, and that's going to be minus 8 times 0.5 plus x. Wouldn't have had an extension of 0.5, it's now extended by x more. The two of them are going to take each other out. What we're going to have is minus 16x. 0.01 a equals 16x. A is going to equal minus 1600x. Omega equals 40. Is that okay with you? Now, the next thing is, it starts at an extreme point, its amplitude is 0.03. Is that okay?
Yeah.
amplitude is 0.03, and it starts at the outside position. Do you use a sine or cosine function for that?
Cosine.
Cosine. So it starts out here, and you use the cosine function to get how it's going. So you say x, its displacement from the centre is x, equals a cos omega t. Now, originally you are 0.03 away. You're the full displacement away from the centre, and you travel how much? 4 centimetre. Okay? So when you travel that 4 centimetre, how far are you away from the middle then? You're going to be 0.02 away from the middle. So x is 0.02. Your a is 0.03. Your cos, your omega is 40, and your t is t. That's 2 over 3 equals cos 40t. Cos inverse it, keep it in radians, and you'll find out that 40t equals cos inverse 2 over 3. T equals cos inverse 2 over 3 in radians divided by 40, and that'll get you 0.02 seconds. Okay.